Hello viewers, welcome to Physics with Sanmitra. I am Sanmitra Bhomik, and in this lecture series on wave optics, we will learn about double refraction today. That comes under the topic of polarization. Okay, suppose we have a crystal here. Let's say this is a calcite crystal. Now we are a light that is unpolarized. This is an unpolarized light. You can see there is vibration along both directions is being incident. Now what will happen, as it is very clear that there will be a refraction according to Snell's law. But one thing it is observed that if we rotate the crystal slowly around a vertical axis, say around a vertical axis, if we rotate the crystal, then what happens is that we get another ray, and that is something like this. We get two images. That is what we actually observed. We get two images. One image that is called E, that is due to this E ray, that is the extraordinary ray, and this yellow one I can say that is O ray, that is ordinary ray. Now what is extraordinary ray and what is ordinary ray? Extraordinary, first of all, there are two images and there are two rays. The first one is my O ray. What is my O ray? That is the ordinary ray, as the name suggests. I can infer that this is the normal refraction what we actually encounter, and it follows the Snell's law. Okay, let me write in a systematic manner. Before that, let me tell you that this will be dot and this will be along the plane. Okay, so up to this, let us understand that we have two rays, that is E ray and O ray, in case of certain crystals, not in every case. Okay, now let me write about E ray, that is O ray, that is the ordinary ray, and about E ray, that is the extraordinary ray. Let me write the difference. Let me write a comparison. First of all, it follows Snell's law, that is mu is equal to sine of I by sine of R. But here it doesn't follow Snell's law. And here mu is not equal to sine I by sine R. Actually, this is not constant. This mu is not constant. Actually, it varies with sine I. Mu should be constant. It should not vary with I or R. It depends on the material, but here it varies with I. That is why when we are rotating it around the vertical axis, this E ray was actually, position of the image was actually changing, but O ray was constant, since we are rotating it around the vertical axis, not horizontal. Okay, now velocity inside crystal is same throughout, but velocity for E ray, this is for O ray, velocity is not same. I'm just writing velocity is not same. Now the last point, that is vibrates perpendicular. Okay, this is perpendicular sign to the principal section, but here vibrates parallel to the principal section. I think this much is clear. Vibrates perpendicular to the principal section and vibrates parallel to the principal section. That is why, if you remember, let me draw it again. This is my, say, the calcite crystal, and this is the unpolarized light. Now there was a refracted ray, and there is this E ray and there is the O ray. This is the O ray and this is the E ray. The O ray, I told you, it will be dot. and here it will be like this. This is parallel and this is perpendicular. This is E ray, this is O ray. That's it. I think this much is clear. Now let us talk about the crystals. Okay, suppose let me take this crystal. This crystal will have an axis. Let's join these 2 points, and this axis will be known as optic axis. Now what is optic axis? Optic axis is such an axis if the incident ray, that is the, let's say this is the plane polarized unpolarized light, if this is parallel to this axis, then parallel to this ray I can say velocity of O ray and velocity of E ray, those two will be equal. That is VO is equal to VE. Velocity of ordinary ray and velocity of extraordinary ray both will be equal. That is in case of optic axis. Optic axis is such an axis, and by the presence of optic axis we can say that on the basis of number of optic axis we can say there are 2 types of crystals. One is uniaxial, one is biaxial. What are uniaxial crystal? Uniaxial crystal has only one optic axis. This has 2 optic axis in case of biaxial crystal. Uniaxial crystals are further divided into positive uniaxial crystals and negative uniaxial crystals. Now what are positive and what are negative? See, in case of positive uniaxial crystals, in case of positive, my VO, that is my ordinary ray, that will be greater than VE, that is the velocity. In case of negative, definitely the opposite will occur. VE is greater than VO. And when VO is greater than VE, I can also conclude that in the first case, okay, let me keep this aside. We'll just deal with uniaxial. Biaxial will come later. When VO is greater than VE, I can write mu O is less than mu E, because mu is equal to C by V, and here V is greater than VO, so mu E is less than mu O. I think this much is clear. Positive and negative uniaxial crystals. And for example, let me give you an example also for each type. For positive uniaxial crystal, I can tell an example for positive uniaxial crystal is quartz, where VO is greater than VE. And for negative uniaxial crystal, one example I can say that is calcite. That example which we took. We'll be talking about this velocity, how this VO and VE, this magnitude is important in case of the quarter plate and the half plate wave. Okay, now half wave plate and the quarter wave plate. Okay, so, and what are the examples of biaxial crystal? Biaxial crystal, we can say one example, that is cane sugar, mica, topaz, etc. These have 2 optic axes. So along 2 such planes, 2 such axes, if the rays are parallel, then VO will be equal to VE. It can this O. So that is my biaxial crystal. And here one more thing, let us study about the geometry of calcite crystal. Let us study briefly about the geometry of calcite crystal. Calcite crystal is also known as Iceland sugar. island sugar, and CaCO3, that is calcium carbonate, a kind, an amorphous. It is a say, it's a kind of calcium carbonate. The formula is CaCO3, and this is also colorless crystal. You can note down these points. Colorless crystal, and it belongs to rhombohedral class of hexagonal system. Actually, these details are not that much important, just for information I'm telling. These are the things which we learn in details in solid state physics, that is the classification of crystal, types of crystal, etc., but not here. In crystallography this is important, but at least we should know about the geometry, because this geometry is important. See, this angle, this is actually like this, not 2D, but it is 3D, like this. This angle, I can say this is 71 degree, and this angle will be 109 degree. Now if we can join this diagonal to this diagonal, or sorry, this one to this one, I can say anything, this actually forms my optic axis. This forms my optic axis. So that's all for this lecture, and if you like our content, then please subscribe to our channel and click on the bell icon. Thank you.